Question 11. This question is about esters including biodiesel, which are long-chain esters. An ester is formed by the reaction of an acid anhydride. Here's an acid anhydride. This is called propanoic anhydride. Normally, they ask about ethanoic anhydride, which has got one C and a methyl group CH3. So CH3, CH3 here. But they made the chain slightly longer to be 3 carbons long. So this is propanoic anhydride rather than ethanoic anhydride. But the reactions are still the same. You react it with an alcohol, and it breaks here. And when it breaks here, if you have a look at it, then this part here, this CH3, CH2, CO, gets the part that's not ringed here. It bonds to the O, CH2, CH3. So it forms CH3, CH2, CO, O, CH2, CH3, and that's the ester. This part at the bottom here, CH3, CH2, COO, gets that ringed H and forms a carboxylic acid. Now normally if it was ethanoic anhydride it would form ethanoic acid, but this time it's going to form 1, 2, 3 carbons, COO, and that ringed H. It's going to form propanoic acid. So this is what it forms. So here you can see again CH3, CH2, CO has got this. There it is. CH3, CH2, CO has now, where it's broken off here, that C has got the OCH2, CH3, OCH2, CH3. And this bottom half, the CH3, CH2, COOH, it's got a carboxylic acid group, that's propanoic acid. What's the name of this ester then? Well, you name esters from the right hand side. That's an ethyl here, CH2, CH3, and then 1, 2, 3 carbons is prop, and an ester, that's something with a COOO in the middle of the chain, ends in O8, so it's ethyl propanoate. In a reaction to form biodiesel, 1 molecule of vegetable oil reacts with an excess of methanol to form 2 moles of an ester with a molecular formula C19H34O2 and 1 mole of an ester with a molecular formula C19H36O2. Draw the structure of the vegetable oil showing clearly the ester links. Okay, so this is what you've got to do. You've got to know about the structure of a vegetable oil. A vegetable oil always has the same structure. It has C, and then it has 3 branches. Okay, so CH2, CH, CH3, so the carbon has 4 bonds, and then it has 3 branches. Each of these are esters, so they all have OCO, OCO, OCO. So this portion of the molecule is always the same, but these carbon chains, these hydrocarbon chains of carbon and hydrogen, can vary in length. And you'll see why I've chosen C17H31, C17H31, C17H33. They could be different, so there could be different numbers of carbons and different numbers of hydrogens. But in this case, the question gives you a clue as to what they are. When you react it with methanol, and you need 3 moles of methanol, and you'll see why in a minute, it breaks it along here. This is where it breaks it, in between the CO, CO, CO. And the OHs, and there are 3 methanols, so 3 lots of OH, join on 1, 2, 3. And you get a triol. Okay, 3 OHs. So that breaks there, and the 3 OHs go 1, 2, 3. And the 3 CH3s join at the other end here. CH3, CH3, CH3. And now I get a long chain ester. This is my biodiesel. So it's diesel that can be put into cars and vehicles, formed from vegetable oil, from vegetables. It's a way of powering cars from a renewable energy source, vegetable oil. Now, why have I chosen C17H31, C17H31, C17H33? When you have a look here, then there's a CH3 that's joined, that's 1 carbon. There's a carbon in the ester group in the CO, so that's 1, 2, and then there's the remainder. Okay, it says here it makes an ester with a molecule of C19H34O2, 2 moles of that, so it's got 2 moles of C19H34O2 and 1 of C19H36O2. So what I do is I work out this portion by subtraction. I know that there's CH3O, CH3, and then the remainder. So if I say C19, well, 2 carbons are in this portion. So that's C19. C19 becomes, this part is C17. So 17, add 1 gets to the 19. H34, well, there's 3 H's in here, 34 in total. 31 add 3 is 34, and 2 O's, which are always there. So I know that this portion is C17H31. It says it makes 2 moles of this, 2 identical. So I've got another one identical underneath. So I've got another C17H31 here. So that's C17H31 and C17H31, because that means that that's C19H34O2 in total. Now this last one, it says a mole of an ester with a molecular form of C19H36O2. So I've got 2 carbons in this portion of the chain, C19, so the rest must be C17 again. H36, well, I've got 3 here, so in here there must be 33, because 33 add 3 is 36, O2, and that's where it comes from. So I take these values here, these molecular formula of the esters that are made, and I take from here, subtract 2 carbons, 2 oxygens and 3 hydrogens, and I find out what the remainder is. The compound C19H34O2 is the methyl ester of ZZ octadeca 9,12-dienoic acid. Part of the structure is shown below. So let's have a look at it. Let's not be frightened by this. It's got, complete the skeletal formula, show the next part of the hydrocarbon chain up to carbon number 14. In your answer, show the Z stereochemistry around both carbon-to-carbon double bonds. So this is my oic acid, this is my carboxylic acid, and this is carbon number 1. Let's just check that out. Carbon number 1, 2, 3, 4, 5, 6, 7, carbon number 8. So this one here will be 9, then there'll be 10, 11, 12, 13, 14. Okay, it'll eventually go up to 19, but only asked me to draw up to 14. So I'm going to have to draw the rest of the chain up to 9, 10, 11, 12, 13, 14. Okay, to get up to carbon number 14. Now, the diene oic acid, well, there's my oic acid, diene, the E has been dropped from there, En, and there should be an E in there, but it's been dropped because you don't have 2 vowels together. That means diene, I've got 2 double bonds, one at carbon number 9 and one at carbon number 12. So I have 1, 2, 3, 4, 5, 6, 7, 8. Carbon number 9 has got a double bond. Then it'll go 10, 11, 12. 12 will have a double bond. Then there'll be 13 and 14. I've got to make sure that there's ZZ. So there's 8, there's 9 with the double bond, 10, 11, 12 with the double bond, 13, 14. And I've put the double bonds in here. Are these ZZ? That's a carbon there. There's a hydrogen off it. Hydrogen has got atomic number 1. The other carbon here, carbon 8, has got an atomic number of 6. So that will take priority. On the right hand side there's a hydrogen coming off here and a carbon coming down. Carbon has an atomic number 6, hydrogen only has atomic number 1. That has priority. So that's Z with both groups taking priority, both carbons on the same side, Z. And 12, again, the carbons coming down this way and the carbons coming down this way. So these two will take priority. That's Z as well. Question 11.4. Give an equation for the complete combustion of C19H34O2. So combustion is a reaction with oxygen. Complete combustion means it's going to make carbon dioxide and water. Incomplete combustion would make carbon monoxide, CO, and water, or possibly some carbon. C19H34O2 plus some O2 makes CO2 and water. I'd start off by balancing the carbons. The carbons, 19 carbons. The only place where carbons go are in the CO2, so there's 19 of those. I know I'm making waters. There's 34 H's, so that's got to be 17, because 2 times 17 is 34, and then I can balance the oxygens here last of all. Let's add it up. 19 times 2 is 38. Add 7, so add 38 for those in there. Add 17, 48, 55. Take away 2 is 53, so 26.5 times 2 equals 53. Combustion of a biodiesel produces greenhouse gases such as carbon dioxide that causes global warming. Part of the infrared spectrum of the carbon dioxide is shown below. State how the infrared spectrum of carbon dioxide in Figure 3 is not what might you expect from the data provided in Table A of the data booklet. Well, here, that you'd expect carbon dioxide would be a carbon with a double bond O and another double bond O, CO2. With 2 carbon to oxygen double bonds, so the carbon has 4 bonds. Yet this doesn't correspond with the C double bond O value. So the absorption at 2350, which is here, does not correspond, doesn't match the data book value of 1680 to 1750 for an expected carbon to oxygen bond. Okay, so this value here doesn't match up with the carbon to oxygen double bond, so something strange is going on with the infrared spectrum of carbon dioxide here. You don't need to know what it is, you just need to identify that this isn't the absorption value for a carbon to oxygen double bond. It should be at 1680 to 1750 instead of at 2350. Explain how carbon dioxide causes global warming. Well, what actually happens is the bonds either vibrate or stretch, and when the bonds vibrate or stretch, they absorb infrared radiation, and the infrared radiation therefore gets trapped. It doesn't escape from the atmosphere, it gets trapped in the carbon dioxide as the carbon dioxide bonds, the C double bond O bonds, stretch and vibrate and hold on to the heat, keep the heat within the atmosphere rather than it being reflected back out of the atmosphere.